Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and sanitizer or soap at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animals and animal product. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Barishal Cadet College. In this class, I am going to discuss linear programming from chapter 2 of your book, Learning Outcome. After the class, you will be able to explain linear programming, formulate of linear programming problems based on the real life problems and solve them graphically. Solve linear programming. Now first, what is linear programming? Linear programming is a mathematical method for determining a way to achieve the best outcome, such as maximum profit or lowest cost in the given mathematical model for some list of requirement represented as a linear equations. Again, I repeat, linear programming is a mathematical method for determining a way to achieve the best outcome, such as maximum profit or lowest cost in the given mathematical model for some list or requirements represented as a linear equations. Now, standard form of linear programming for two decision variables. It consists of the following three parts. First, objective function z is equal to ax plus by. Here, objective function means in linear programming problem, we are to find the maximum or minimum value of linear expression, which is called the objective function. Remember these things carefully. For linear programming problem, we are to find the maximum or minimum value of a linear expression, which is called the objective function. That means z is objective function. And number two, subject to the constraints or restrictions. Here a1x plus b1y greater than equal to c1. These are the restrictions or constants. And constants are the linear equations or inequalities in the linear programming problem. Their solution is graphed as a feasible region, which is the set of points. These points are where the graphs of the inequalities intersect. And number three, x greater than equal to 0 and y greater than equal to 0, non-negative constraint. Always x greater than equal to 0 and y greater than equal to 0. Any point satisfying the condition x greater than equal to 0 and y greater than equal to 0 lies in the first quadrant. The feasible region determined by a collection of linear inequalities in the collection of points that satisfy all the inequalities. The largest or smallest value of the objective function is called optimal value, and a collection of values of x and y that gives the optimal value of constitute an optimal solution. The variables x, y are called the decision variables. The region is said to be bounded when the graph of a system of constants is a polygonal region. So remember a few things. Linear programming The main object of linear programming is to have maximum profit by investing minimum capital. And the three parts are given in linear programming. First part is objective function, that means Z, and second part constants are given, and the third part x greater than equal to 0 and y greater than equal to 0, non-negative constant. If satisfy all this condition, then we say to this is a linear programming problems. Now, formulation of problems in linear programming. Now, how to formulate a linear programming problem? We follow some necessary steps, then we formulate the linear programming problem. Now, first step, study the given situation to find the key decision to be made and find out the deciding variable from the given condition or data related to the problem. Now, firstly, we study the given problem and find the key decision to find out the deciding variable from the given condition or data related to the problem. Then second step, the problem can be expressed mathematically as a function of these variables, and write the function is to be maximized or minimized. This function is called objective function, that means Z. And Z means objective function. The problem can be expressed mathematically as a function of these variables, and write the function to be maximized or minimized. Thus, this function is called objective function. And now step 3. Indicate the given condition properly and express them as a linear equation or inequalities in terms of the variable of the problems. These are called constants or restrictions. Again, I repeat, indicate the given condition properly and express them as a linear equations or inequalities in the term of the variable of the problems. These are called constants or restrictions. Now, step 4. The non-negative factors are separated and expressed mathematically. For example, manufactured materials cannot be negative. That's why if the material is X, then X greater than equal to 0. Now we follow these 4 steps when we solve linear programming problem. When we formulate a linear programming problem, then we follow these 4 steps. First, we decide the key decision and the deciding variables, then expressed in, this is in mathematically, that is objective function, then indicate the given condition properly, and then the 4th step is X and Y greater than equal to 0, because materials cannot be negative. Now, solution of problems as linear programming with the help of graph. Always we try to solve all the linear programming problems with the help of graph. For this reason, we follow few steps to solve linear programming problem graphically. The first step, step 1. The lines XO, X dash and YO, Y dash are taken as the axis of coordinates. Sketch the straight line obtained by replacing all the constant of linear equation in the form of x by a plus y by b is equal to 1, which passes through the point a, 0 and 0, b. Then use this thick line if the is equal to, is included less than equal or greater than equal, and the thin line of the inequality is to restrict less than equal or greater than equal. Then step 2, choose a test point. Note on the line 0, 0 is a good choice if the line does not pass through the origin. And if the line passes through the origin, a point on one of the axes would be a good choice. Then step 3, if the test points satisfy an inequality, then the set of solutions in the entire region on the same side of the line as the test point. Otherwise, it is the region on the other side of the line. Remember carefully this step. If the test points satisfy the inequality, then the set of solution on the entire region on the same side of the line as the test point. That means towards the origins. Otherwise, it is the region on the other side of the line. Then step 4, the feasible region. We determine a feasible region by collection of linear inequalities is the collection of points that satisfy all the inequalities. And step 5, find the coordinates of the corner points or vertex if the feasible region. And step 6, substitute the coordinates of the corner point into the objective functions and select the point which gives the optimal value. This point gives the solution to the linear programming problems. We follow these necessary steps when we solve linear programming problem graphically. Now let us try to solve some linear programming problems. Here given, a fruit merchant wants to purchase grapes and oranges taka 5,000, but his warehouse cannot accommodate more than 12 carton. Each carton of grapes and orange respectively cost of taka 250 and 500. He sells each carton of grapes and orange at a profit of taka 6 and 10 respectively. His total purchase is sold every day. How much grapes and orange he should purchase for the maximum profit? This is our given question. Now we divide this question into two parts. First part, formulate linear programming problems, then solve it graphically. Now first, study the given situation to find the key decision to deciding the variables. Here, how much grapes and orange he should purchase for maximum profit. That's why solution, let he will purchase X box of orange and Y box of grapes. Here X and Y are the decision variable for this. Here X box orange and Y box grapes. Then the objective function. We know objective function meant to find maximum or minimum value. Here we find maximum value. That's why we can write Z maximum is equal to here profit. He sells each carton of grapes and orange at a profit of taka 6 and 10 respectively. That's why we can write Z maximum is equal to 10x plus 6y. This is our objective function. Now, then expressed the problem in mathematically and indicate the given condition properly. Here given some conditions. Here first condition here given, the warehouse cannot accommodate more than 12 cartons. And the another conditions, the grapes and orange are cost 250 and 500, and the total purchase is 5,000. That's why we can write here the conditions. His warehouse cannot accommodate more than 12 carton. That's why you can write x plus y less than equal to 12. And the second condition is cartons at 500x plus 200y less than equal to 5000, and x greater than equal to 0 and y greater than equal to 0 always. Then this is our formulation of linear programming problem. Now we solve it graphically. Now firstly we replacing all the inequalities into linear equation in the form x by a plus y by b is equal to 1. Then find the intersecting point. Now equation corresponding to given conditions are here. The first conditions x plus y is equal to 12. That means we can write x by 12 plus y by 12 is equal to 1, because we compare these constants or inequalities into x by a plus y by b is equal to 1. Now we find the intersecting point. Here the intersecting point 12, 0 and 0, 12. And another here given another constants or inequality 500x plus 250y is equal to 5000. Here given two inequality, first one and second one. That's why we can write 2x plus y is equal to 20. That means x by 10 by y by 20 is equal to 1. Here the intersecting point 10, 10, 0 and 0, 20. Now, and x equal to 0 and y equal to 0. Now let x o x dash and y o y dash be the x and y axis, and o is the origin. Now putting this value in the graph paper, here the first intersecting point 12, 0. That's why we're gonna 12, 0 and 0, 12 and 0, 12. That means these lines. And the first constant or inequality, these lines, and the second line 10, 0 and 0, 20. That means 10, 0 and 0, 20. Along both axes, one unit is equal to one side. From equation 1 and 2, we draw the graph of the lines. Then we find or we determine the direction of the line or the inequality. For this, we put 0, 0 of the constants. If the condition is satisfied or if it is true, then the direction on the same side of the line or test point. Otherwise, it is not. Here, if we put 0 and 0, that means x0, y0. That means 0 less than is equal to 12. This is true. And here, if we put here 0 and 0, that means less than equal to 5,000. That means it's also true. That's why we can. That's why we given here this indicator this towards of the origin. Otherwise, the indicators opposite sides of the line. We put 0, 0 of the constant. Then if it is true, then the direction on the same side of the test point, because 0, 0 means here. That's why we indicate these lines towards of the origin. Now we find the feasible region. To determine the feasible regions, to satisfy all the inequalities. Here we see the satisfy this part, that means, and here we satisfy this part, but two lines are satisfied this part only. That's why this is called the feasible region. Feasible region. Then find out the coordinates of the vertex of the feasible regions. Then here the find out the coordinates. That means 0 means 0, 0, O means 0, 0, and here this point, that means 10, 0, and the intersecting point, corner point here, C, that means 8, 4, and another point is here, that means 0, 12. Now putting this point on Z, or substitute all the coordinates of the corner point into the objective function, then we find our required solution. Now the points which satisfy all the conditions lie inside the quadrilateral OSCB and on each side. Extreme points are edge O00, A10, and C84 and 012. Now putting this value 00 at 00, that means Z is equal to 0 plus 0 is equal to 0, and A is equal to 10, 0. That means 10 into 10 plus 6 into 0, that means 100. In the same way, we can write this B012 is equal to Z is equal to 72. Now we find the maximum value of Z. Here you see the maximum value, that means the highest number, 104. That's why the maximum value of Z at C is 8,4. So he will purchase 8 boxes of orange and 4 boxes of grapes for maximum profit. This is our required answer. Now let us try to solve another question. A man wishes to purchase 6 pieces of napkin and 4 pieces of towel within an amount of 500. The cost of each napkin and towel are respectively taka 30 and 40. How many of each kind should be purchased so that under the condition he may purchase the highest number of articles? So first part is formulation a linear programming problem, then solve it graphically. So first study the given question, then find out the key decision point or deciding variables. Here the deciding variables are X and Y. So he will purchase X piece of napkin and Y piece of towels. Then objective function Z is equal to X plus Y, because here no given profit or loss. That's why the objective function Z is equal to X plus Y. And the given conditions, here the conditions, a man wishes to purchase 6-piece napkin. That means almost highest 6 piece. That's why we can write X greater than equal to 6, and 4-piece towel. That means Y greater than equal to 4. And the another conditions is napkin and towel. The cost price is napkin and towel as 30 and 40 taka. That's why, and within the amount of 500, he purchased within 500. That's why you can write 30x plus 40y less than equal to 500, and x greater than equal to 0 and y greater than equal to 0. Always this term, because napkin, the number of napkin and towels are not negative. This is our formulation of linear programming problems. Now let us try to solve it graphically. So equation corresponding to given conditions are X is equal to 6, question number 1, and y is equal to 4. Number 2, and another inequality, 30x plus 40y less than equal to 500. That means 30x plus 40y is equal to 500. That means 3x plus 4y is equal to 50. Now let us try to replacing the linear equation in the form of x by a plus y by b is equal to 1. That's why we can write x by 50 by 3 plus y by 25 by 2 is equal to 1. This is equation number 3. Now we putting and x equal to 0, y equal to 0. Now putting all this value in the graph paper. Let x or x dash and y or y prime be x and y axis, and O is the origin. Scale along both axes, 1 unit is equal to 1 side. Draw the graph paper line of the above equation. Now we're putting all the equation here. 1, 2, that means x equal to 6, y equal to 4, x equal to 6, that means parallel to y-axis, y equal to 4, that means parallel to x-axis, and here the given point 50 by 3, 0 and 25 by 2, 0. Now putting all the value here, then we can write here x o x dash, x o x prime and y o y prime are the axis of x-axis and y-axis. Then first first equation, x is equal to 6. That's why we can write 1, 2, 3, 4, 5, 6 parallel to x-axis. That means x is equal to 6. Now another equation, question number 2, y is equal to 4. That means parallel to y-axis. Here y is equal to 4. And equation number 3, here the intersecting point 50 by 3, 0 and 25 by 2, 0. That means 50 by 3, that means 12 point something. That's why this point, and 25 by 2, that means 12 point something. That's why here these points. Now we determine the direction of these 3 lines. Here x is equal to 6 or x greater than equal to 0. If we put x equal to 0, then is not true. That's why the direction here other side of the line. And if we put constant number 3 or inequality 3 of 0, 0, it is true. That's why this direction towards the origin. And if we put y equal to 0, here the given line constant a, if we put x equal to 0, that means this is not true. That's why the direction other side of the line. Here if we put y equal to 0, this is not true. That's why the direction other sides of the line. And if we put x equal to 0 and y equal to 0 here, then this is true. That's why this direction towards the origin. That's why these lines here towards the origin and others 2 lines are opposite sides of the origin. Now let us try to find the feasible region. That means satisfy all the inequalities. Here you see this part, that means this region, total region, but here this region, that means this total region, and y is equal to 0. Here this part satisfies all the 3 inequalities. That's why this is our feasible region. Now we find the corner point or vertex, indicate the corner point of vertex. Here the first point P 6, 4 and Q S is 10,6 and R 6,8. Now we're putting this value in the objective function of Z. Then if P equal to 6 4, then Z is equal to 6 plus 4, that means 10. Q is equal to 15 point something, and R is equal to 14. And the maximum value of Z of point Q, here you see the highest number of this. That's why we can write the maximum value of ZQ, which is the fraction, but the number of this cannot be fraction. That's why we're putting y is equal to 5 in the equation 3, then we get x is equal to 10. The point S is equal to 10, 5 lies on the line 3 and satisfy all the given conditions. So the number of the napkin X is equal to 10 and the number of the towel Y is equal to 5. This is our required answer. Now another question. A man wants to purchase a pen and pencil with an amount not exceeding 100. Each pen cost 12 and each pencil cost 8. Find how many of each kind of he can purchase, so that under the condition that he will purchase at least one pen and at most 8 pencils, so the total numbers may be maximum. So first, let x and y the key decision or decision variables of the numbers of pen and pencil respectively purchased. Then the objective function z is equal to x plus y. Now the given condition. Here the given condition, each pen cost 12 and each pencil cost 8, and the total note amount not exceeding 100. That's why you can write 12x plus 8y is equal to less than is equal to 100. And the another conditions, x 3x plus 2y less than is equal to 25. That means 3x plus 25 less than 25. And another condition, x greater than equal to 1 and y less than equal to 8 and y is greater than equal to 0. Now corresponding linear equations of the given inequalities 3x plus 2y is equal to 25. Now question number 1, which passes through the point 5, 5 and 3, 8, and x is equal to 1 and y is equal to 8. Question number 3, and y is equal to 0. Now putting this value on the graph paper, then we can see this is our graph paper. Then we find the direction of these lines. In the same way, we can, if we put 0, 0 on the inequalities, then we see this is, if we satisfy all the condition, then the direction on the towards the origin, otherwise it is another side of the origin. Here we can see this is satisfy. That's why this line towards on the origin and other lines another side of the origin. So this is our feasible region. This is our feasible region. Now putting this value in Z. So here you see A, that means 1 0, and B 25 by 3 comma 0, and 1 and 2 intersect at 3 and 4, and 1 2 intersect D at 1 8 here. Now putting this all these 4 point of Z, then A 1 0, that means Z is equal to 1, and B 25 3, that means 25 by 3, and C is equal to 11, and D, that means 9. So the maximum value of this is 11. This is our required answer. 11, that means here 3 pencil, 3 pen, and 8 pencil. is required to the number of pencils 3 and 8. This is our required answer. Now another question. The protein and fat contents per kg of two foods A and B is as follows. Type of diet A and B and minimum daily requirement. Proteins unit per kg 1, 3 and minimum requirement 9. And carbohydrate units per kg required is 3, 12, 2 and minimum daily requirement 12. And price per kg is 2 and 3. Now first formulate in programming problem, then solve it graphically. So how can the minimum requirement be satisfied at least at the least cost? Express the fact as problem in the linear programming and solve it with the help of graph. So first formulate the linear programming problem. Almost all the problems when given this type of chart, Z is price of taka or profit or loss here given last column. This is we consider Z, and this is the conditions of first condition 1, 3 and 9 and second condition 3, 2 and 12. Now let us put it mathematically. Let us try to write mathematically of this data. Let x kg of food A and y kg of food B taken daily. So the total cost Z is equal to 2x plus 3y. This is our objective function here, 2x plus 3y. Now the first conditions x plus 3y less than equal to 9 and second condition 3x plus 2y less than equal to 12. So the first condition here, the minimum daily requirement, that means minimum 9. That's why we can write x plus 3y greater than equal to 9 and 3x plus 2y less than equal to 12 and x greater than equal to 0 and y greater than equal to 0. So corresponding linear equations of the given inequalities are now x plus 3y is equal to 9. Now we replacing all the inequalities in the linear equations in the form of x by a plus y by b is equal to 1 and find the intersecting point. So replacing all the inequalities of linear equation, that's why you can write x plus 3y is equal to 9. That means x by 9 plus y by 3 is equal to 1. And the intersecting point 9, 0 and 0, 3. Now another question, another line. Here another inequality is 3x plus 2y is equal to 12. That means x by 4 plus y by 6 is equal to 1. And x is equal to 0 and y is equal to 0. Now putting this value in the graph paper, then we can write here first inequality 9, 0 and 3, 0, 3. That means here 9, 0 and 0, 3. And the second 4, 0. That means here 4, 0 and 0, 6. That means here if we put 0, 0, then if we put here 0, 0, 0 greater than equal to 9, this is not true. That's why the directions of the line opposite of the origin. In the same way, if we put in here 0 and 0 that greater than equal to 12, this is not true. That's why the direction of the line opposite of the origin. Now let us try to find the feasible region. Here that means satisfy all the inequalities. Here you see this is the direction here. This is our feasible region. So the corner point or vertex here, the given vertex here A, B and C. Now putting the point A 90 and 1 to intersect and B 18 by 7 and 15 by 7 and C 06. Now putting this value in Z at the point A 90, the cost Z is equal to 2 into 9 plus 3 into 0, that means 18. In the same way, we can write putting the value of this 2, then the required minimum cost. Here you see the minimum cost. Here this point 18, 18 and 11 point something. That means this is our minimum cost. So the minimum required food, the cost 18 by 7 kg of A and 15 by 7 kg of B should be taken. This is our required answer. Now another questions. If the linear programming are given, then we solve directly in graphically. Here given minimize Z is equal to 3x plus 4y and subject 2x plus 2y less than equal to 8. 3x plus 2y less than equal to 12 and x greater than equal to 0 and y greater than equal to 0. So solution, the feasible region determined by the system of constants. That means the same way we determined the point A00, A40 and B23 and C04 and putting this value on the graph paper. This point 00 here, that means here, and A40, that means here A40 and B23, 23, that means 2, 3 and C04, that means here 2, 3, that means 2 and 3 here. Now putting all these four points here, then let us try to find the feasible region. Here the directions. If we put 0, 0 here, that means 0, 0 less than equal to 8. This inequality are true. That's why the first equation, the direction of the first equation of the towards of the origin, and if we put here 0, 0, this is also true. Then the second equation, the directions of the second equation towards of the origin, and here you see here satisfy all the inequalities this part. That's why this is our feasible region. So now find the corner points of the feasible region. Here you see this point, and this point, and this point. These 4 points are the vertex of the feasible region. Now we put these 4 points in Z, then we get the minimum value of Z. So the corner point of the feasible region Z are given below. First one 0, 0 or 0, 0, that means Z is equal to 0. Second point A 4, 0, that means Z is equal to x is equal to 4 and y is equal to 0. That means Z is equal to minus 12. And third point B is equal to 2, 3, that means here x is equal to 2 and y is equal to 3. Putting here, then Z is equal to 6. In the same way, we can write C is equal to 16. Hence, the minimum value of Z is, here you see, the minimum value of this fourth term is at minus 12. That's why we can write the minimum value of Z is minus 12 and at the point 4, 0. Now, another question. Minimize and maximize Z is equal to x plus 2y and subject to here this x plus 2y greater than equal to 100 and 2x minus y less than equal to 0, 2x plus y less than equal to 200, xy greater than equal to 0. Now solution. Firstly, we convert all the constant into linear equation in the form of x by a plus y by b is equal to 1 and then find the intersecting point. Here the intersecting point, if we convert of these 3 inequalities of linear equation, then we get these 4 intersecting point. Now we putting this intersecting point on the graph paper. Here a 0, 50. That means 0, 50. Here 0, 50. That means here and 0, 50, a 0, 50 and b 20, 40. That means 20, 40. and C 50, 100, 50, 100, and D 0 to 100, 0 to 100. Here putting all this value, then we find the direction. Now let us try to check here 0, 0. These constant are, this inequality are true. If we put 0 and 0, this is true. If here, if we put 0, 0 less than equal to 0, that means it's also true. If we put 0, 0, that means this inequality is also true. That's why all the directions of the lines are towards the origin. And now let us try to find the feasible reason. Here you see, satisfy all the constraints. Here this part are satisfy all the constraints. That means all the three lines are satisfied. This lines here, this lines here, and these directions here. Now let us try to find the corner point or the vertex of the feasible region. Here A, B, C, D are the corner point of the vertex of the feasible region. Now putting these 4 points in Z, then we find maximize or minimize value of the linear programming problems. A 0, 50, that means Z is equal to 100. B 20, 40, that means Z is equal to 100. C 50, 100, that means Z is equal to 250. And D 0, 20, 200, that means Z is equal to 400. Here the maximum value of this fourth term is 400. So the maximum value Z is equal to 400 at the point 0, 200, and the minimum value is 100 of the point 0, 50 and 20, 40. Now this is your homework. A firm manufactures chair and table. Two machines A and B are used for processing. A can be used for 60 hours and B for 48 in a week. A takes 2 hours and B takes 4 hours to make a chair. A takes 4 hours and B takes 2 hours to make a table. If the profit in each table and chair are respectively taka 80 and 60, how many chair and table should be manufactured to have a maximum profit? And question number B, find graphically the minimum value of Z is equal to 3x plus 2y and the conditions x plus y greater than or equal to 1 and y minus 5x less than or equal to 0. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing in this critical situation. You must stay home and keep yourself safe. Stay fine. Thank you.